Hey everyone, so in this video I'm going to go over the normal curve and mean and standard deviation. So the normal curve is a bell-shaped curve. The normal curve describes things that happen in the world that would have an average. Something that's very common is like an SAT. SAT scores, people score here majority of the time. This hump or this peak of the bell curve is where the most scores would have been, and that's typically where most people would score on the SAT. And then you have some people who score really high on the SAT and some who score really low on the SAT. So the reason why the bell curve worked for this scenario is that it shows the distribution. What distribution means is spread of the data, where the most would be in the middle. Another good example is like height and weight of a certain age. So like when you're a toddler, a male or a female, they should be around typically the same peak at a certain age. And then some people are really tall and some people are really short, but you see majority here. This middle part is usually our mean. You would depict that as x bar. Now, to show the spread of our data, we use something called standard deviation. Okay, so what we want to understand is that the mean is the center and the standard deviation is your spread of the data. So spread meaning that we want to see how far someone is from the middle. So that being said, we usually do 3 standard deviations above the middle and 3 standard deviations below the middle. So what I'm going to do is I'm going to show you how to put 3 above and below. So this would be 1 standard deviation, 2, and 3. So 1 standard deviation, 2 standard deviations, and 3 standard deviations. I'll explain what that means in a second. Then you would go the other way. -1 standard deviation, -2 standard deviation, and -3 standard deviation. So let's say, I don't know, the mean was 100 for something, and the standard deviation was 25. What that means is that I would add 25 to 100. So I would get 125. So let's say weight of a male at age whatever. So let's say the average at this age is 100 pounds, and then you have 125 pound people, 150, and 175. All I'm doing is adding the 25, because in this case our mean was 100 in this example, and our standard deviation was 25. Okay, so then I would go backwards and I would subtract 25. So -1 standard deviation would be 75, and -2 would be 50, and -3 would be 25. Okay, so these are in pounds, and what this describes is people that are really overweight, average, and really underweight. If you're over here on the tail ends of the bell curve, this is something that's considered rare and unlikely to happen, so we like to analyze these people over here. But the middle is where the most are usually grouped. Okay, so again, the bell curve is called the normal curve. It describes things that happen with an average and some that are above and some that are below. Sometimes people call it mound-shaped, but it's a nice spread. It's also called symmetrical because this tail and this tail are even. These are called the tails. Okay. So I'm going to go over this example. We have a few bell curves here. I can see right away that histogram 1 is a normal bell shape, and so is histogram 3. Remember, a histogram is a bar graph that has the bars touching. Now for these two guys, histogram 2 and histogram 4, they are not normal. If you notice, their tails are towards the right. These would be considered skewed to the right. Now, you know how I have my silly little ways of remembering things. In my brain, this here is like a dinosaur. I don't know if you can see it. And this is his tail, like a stegosaurus. I don't even know what that's called, but that would be his tail. Okay, so that's what I think of. So this is we right skewed for these two. And then this is normal. Okay. So again, the normal was the bell shape, and this right skewed has that tail to the right. Okay. So now what we're going to do is we are going to analyze these bell curves and try to figure out where the center is and where the spread is. So the mean for all of these are 100, which kind of helps us out because you can see all the centers here are at 100. Okay. So the standard deviation tells you how spread apart the data is. Okay, so what this means is that I'm going to see what fits better. The 10s are smaller standard deviation, where the 40s are a larger standard deviation. This depicts a small spread of data, and this depicts a large spread of data. Remember, the standard deviation is your spread. So if I look at the first histogram, I want to see if I can count 10 above 3 times. So like this is my mean, X bar. This would be my 1 standard deviation, my 2 standard deviations, and my 3 standard deviations. Now that's a great fit because even when I subtract 10, I would get 90, 80, and 70. And if you can see, the data is completely covered when I add 10s above and below. So this would probably be approximately symmetric and mound shaped. So this would be graph B. Okay? Now looking at the next one, I know it has to be either, well, we already chose B, so by process of elimination it would probably be C. And I'm going to describe why it would be C right now. And the reason why it would be C is because if you added, so here's my 100, if you added 10 to the 100, you would have 110, 120, 130. It would not cover the whole data. But if you add 40, like they're saying, that would be 140, 40 plus 40 is 180, and then plus 40 would be 220. And then if I went the other way and I did 100 minus 40, I'd get 60. And then, oh, over here, 60. And then if I do that subtracted by 40, I get 20. And then subtract that by 20, you'd get, 40, you get negative 20, but that's okay because overall it would cover all the data. So this would be graph C because of that. Okay, now looking at these two, these are both skewed right. Now you just got to figure out which one has a larger spread. And you can notice that histogram 4 has a larger spread. So that's probably the one that is graph C. And then this one would be graph B. Graph A. By process of elimination. So what this means is that if I added 10, I would get 110, 120, 130, and that would cover the right side of the graph, which is great. And if I subtracted 10, I would get 90. I know it doesn't go all the way over here, but it would be way better of a choice than having 40. So just overlooking this all, basically all these had a center of 100 because that's where the bell curve or the non-bell curve, because the histogram 2 and 4 weren't bell curves because they're skewed. That's where they balance. That's what we called center. It's the balancing point of the distribution. And the determination of which one was the standard deviation was because of the spread of the data. So a smaller spread was the 10 and the larger spread was the 40. So distributions, here's your summary, are described by the shape, symmetric or skewed, the center and spread of variability of the distribution. Distribution approximately symmetric can take different forms. We want mound shape is approximately symmetric, has a single peak, so that's here, boom, that's your bell curve. Oh, that looks really bad. Okay. A distribution skewed to the right. So remember, skewed to the right is when the tail is to the right, and skewed to the left is when the tail is to the left. The mean of the distribution is typical value, and it's the average that make up the distribution. And the standard deviation is a value that describes a typical distance from the mean. Okay, so I'm going to do the 2 examples on the homework that go here because they ask you to find the standard deviation and the mean, so you can get a little bit more of an understanding of this. So when we look at these two, they first say, for each distribution histogram, describe the shape and give an estimate of the mean standard deviation. So looking at this guy, the shape is bell curved, approximately symmetric, whatever you prefer. I'm going to write bell curve. You could say approximately normal also. Okay. Can't really write. That's pretty bad. Normal. Either these mean the same thing. You could say mound shaped, mound shaped. These are all acceptable answers. Okay, and they want you to estimate the mean. The mean is your balancing point. So that's where the highest peak is. So I'm going to say about 560 would be my mean. Okay, now my standard deviation has to allow me to count 3 above and 3 below at least. So I need to find a value that would allow me to encompass the data 3 above or 3 below. So if I did say 20, would that be a good fit? So 560 plus 20 would be 580. 580 plus 20 would be 600, and then 600 plus 20 would be 620, and that's pretty good. So I would say about 20, 25. If we wanted to do 25, let's see if that was better. 560 plus 25 would get me 585, plus 25 would get me 610, plus 25 would get me 635. So actually 25 might be better, because adding 25 and subtracting 25 would probably encompass all the data. But let's see, if I do 560 minus 20, I get 540. And if I subtract 20 from that, I get 520. And if I subtract 20 from that, I get 500. So I'm actually going to go with the 20 as my standard deviation, because if you notice, if I did 25, I'd be really far off the end. So 20 is probably the better of the two, but it really wouldn't matter. Okay, here's another example. So I'm going to try to find, this is about mound shape also, because I can draw kind of like a bell curve over it. I'm going to try to find the center. This looks like a good center, about 1900, so that my mean would be about 1900. And remember, I need to count 3 above and 3 below. So let's see, if I count by 1,000s, I would get 2,000. Well, hold on. So 19,000 plus 1,000 would get 2,000, and then 2,100, and then 2,200. Not bad. And if I subtract, I'd get 1,800, 1, 1,700, 2, and 3. So that's a little bit off the data, but it does encompass most of it. So I'm going to say my standard deviation is about 1,000. This is just an estimate. So again, the mean is your center. The standard deviation is your spread. You want to make sure you can count at least 3 above and 3 below. And also, whether or not it's mound shape is when it has that nice little peak in the middle. And also, if skewed right would be the tail would be on the right, and skewed left would be the tail would be on the left. I hope this helps you guys with this lesson, and I hope to see you soon.